Today we're in lesson 1.5, and in this lesson we're going to look at some postulates and theorems that relate points, lines, and planes. Points, lines, and planes are the big idea of this first chapter. So today we're going to learn some of the relationships between them. So we talked about what a postulate was earlier this week, and saying that a postulate is a statement we accept as being true, and we don't worry about proving it. We just kind of read it and go, yeah, that makes sense. These postulates are numbered. So it just says postulate 5, postulate 6, postulate on up to 9. Do not worry about memorizing those numbers. I will never ask you, what does postulate 7 say? I don't know what postulate 7 says, because it's not worth memorizing. That's just a number a book gave it. It doesn't mean anything. Somebody who's using a different geometry textbook would have a different number for it. So they're all true, they're important, but they don't have names, so don't worry about knowing those numbers. Okay? I will never ask you to state what any of these say. Okay? So you don't need to be able to write them out, you don't need to have them memorized. You do need to understand the concept that's there. You have to understand what it's saying and understand the idea, but you don't need to be able to write them out or say them.
Well, we need to know the definition of a postulate.
You do need to know what a postulate is, yeah. Yep. And if the postulate has a name, then you should know it by name. So we had some this week that had names, like the segment addition postulate and the angle addition postulate. If it's important enough to have a name, then that name is something that you should know. That would be consistent to anybody in any geometry textbook doing geometry anywhere. Segment addition postulate means the same thing. Postulate 7 could mean something different to everybody. Okay? Alright, so what these say. Pictures speak louder than words, so we'll kind of work our way through and draw some pictures here. So postulate 5 says, a line contains at least 2 points. So if I have a line, there should be at least 2 points on it. Well, when we said what a line is, we said a line is actually completely made of points. So yeah, there has to be at least 2 there. Then it says a plane has at least 3 points that are not all in one line. So I've got a plane and it's got 3 points that aren't in a line. Then space has 4 points that are not all in one plane. So if I bring in a 4th point, that now covers everything. So postulate 5 is like a progression postulate. It says if we start with 2 points, we have a line. If we bring in a 3rd point, we have a plane. If we bring in a 4th point outside of that plane, that gives us everything of space. Okay, so it's progressing on up. 2 points make a line, 3 points make a plane, 4 points make space. Okay. Postulate 6 says through any 2 points there is exactly one line. That means there's only one way to do this. If I gave everybody a marker and said connect the dots, you have to do it the same way. There's no room for creativity in this. 2 points, connect the dots, only one way to do that. Postulate 7 says through any 3 points there is at least one plane. Through any 3 non-collinear points there is exactly one plane. So if I have 3 points that are not in a straight line, there's only one way to put a plane around those. If I have 3 points that are in a straight line, there's lots of ways to put planes on those. So I could do a plane this way and contain them, or I could do that plane that way, and I'm still containing those 3 points. So if I have 3 points that are not in a line, there's only one way I can draw a plane that's going to catch them all. If I have 3 points that are in a line, I could draw lots of different planes that would catch those points. I can only draw 2, but there's really lots. I just can't, I'm not good enough at art to draw more of them in there. Postulate 8, if 2 points are in a plane, then the line that contains those points is in the plane. So remember, we can think of a plane like a sheet of paper. So what this postulate's really saying is if you take a sheet of paper, or a plane, and you draw 2 dots on it, or points, and then I ask you to connect the dots, you have to do it on the paper, right? The wall, that's not connecting the dots, because the points are on the paper. So that's what this postulate says. If points are in the paper and you want to connect the dots, you have to do it on the paper where the points are. So that's what postulate 8 says. If 2 points are in a plane, then the line is in the plane too. Postulate 9 says if 2 planes intersect, their intersection is a line. So that same picture at the top would work for this one as well. Now when 2 planes intersect, the only way they can meet each other is in a line. Questions on what any of these postulates say? And remember, you don't have to be able to state them. You don't have to have them memorized. You don't have to know what numbers go with what. You just have to understand the ideas that are there. Okay, so the other day we talked about the 4 parts of a mathematical system. The first part is undefined terms. There are 3 of those. What are they? Point, line, and plane. And those are 3 undefined terms. They are our building blocks. On Friday's test, if I ask you define a plane, you should say, I can't. There isn't one. Plane is undefined. Okay, point, line, plane, undefined. Then we've defined terms. We've defined lots of terms. Segment, ray, angle, vertex. We've had lots of terms that we've had definitions for. Then we've had these things called postulates, which are statements that we accept as being true, even though we don't prove them. We just say, yeah, that seems like it would have to work. If 2 points are in a paper and I connect the dots, I'm connecting them on the paper. Seems to make sense. We have not had any theorems yet, but we will now. Theorems are statements that can and must be proven, or should be. Okay? Theorems are statements that we want to not just believe, but say why. Why is it that way? Why does that work? Let's make sure. Okay. So we're going to have 3 theorems today. Again, they don't have names. You don't need to worry about memorizing exactly what they say or learning their numbers. That's not important, but understanding the ideas here. We're not going to begin proving yet. Okay, so theorems are statements that should be proven, but we're going to hold off on that here. We're not going to start doing proofs yet. Soon enough. If 2 lines intersect, they intersect in exactly 1 point. So because in geometry, when we talk about lines, we're talking about straight lines, they can't come around and meet each other again. So if 2 lines are intersecting, the only thing they can possibly have in common is 1 point.
Is a parabola considered a line?
No, not in geometry. All lines in geometry are straight lines. Our second theorem says, through a line and a point not on the line, so I have a line and I have a separate point, there is only 1 plane that can contain all of that. If we were going to prove this, what we would do is say, well, that line has to have a couple points on it. One of our postulates said that. And now I've got 3 points that are not in a line, and one of our postulates says that has to be a plane. So that's kind of how we would go through the idea of proving this, building off of those postulates. But we're not going to do that yet. Theorem 3 says if 2 lines intersect, then exactly 1 plane contains those lines. Again, if we were going to go about proving this, we would say, okay, well, each line has to have at least a couple points on it. So then I'm getting points that are not all in 1 line, which then, like the last one would mean, that has to be 1 plane. Okay, so that's kind of how we would work our way through a proof, but we're not going to do that yet. These theorems build off of the postulates. Questions on what any of these say? Exactly, or 1 and only 1 in a theorem or a postulate means that it has to exist and that it's unique. There's only 1 way to do it. So when 2 points are connected with a line, there is 1 way to do it. It is possible always to connect 2 points, and there's only 1 way to do it. So when we see the word exactly or 1 and only 1, it means it has to be able to happen, and there's only 1 way that it can happen. I decided last night when I was looking through the notes, I don't really care too much about these problems that talk about the word determine. There's none of those problems in your homework, so we'll just skip on past those. So then in your homework, you won't be doing proofs, but you are going to be using these postulates and theorems to do what we call justifying, which is giving a reason for saying what we're saying. Okay, so it's kind of answering that question, why? I at home have a 2-year-old and a 3-year-old. So the question why, like, kills me right now because it's constant. Why? 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 And then I say, stop asking why. And my son starts going, how come? How come? And I'm like, ah! But that's what a proof is it's constantly asking why. How do you know that for sure? Prove it to me. Okay? So what we're going to do is answer the question and then say, how do we know that we actually can do that? By naming off one of these postulates. You can just use the numbers when you're doing your homework. You'll have the list in front of you, so you don't have to memorize them, but you can just use your notes and just name off the numbers if you want instead of writing out the whole thing. Okay, that's fine with me to just answer with the numbers. There's a point missing on here. I don't know why. We should have up here a point called C. I don't know why that didn't come through. So our first question says, name 2 points that determine line L. So we have line L in the picture. We need to name 2 points that would make up line L. So that would be point C and point A. They make up line L. There's a lot of other points there too, but they're not named. So point C and point A together would make up line L. Now, we have to say, how do I know that 2 points make one line and no other lines? So then we look at our postulates for one that talks about 2 points making up one line, and that is postulate 6. Postulate 6 says that when you have 2 points, there's exactly one way to get a line out of that. The next question says, name 3 points that determine plane M. So to end up with plane M, which is the vertical plane in this picture, we need to find 3 points that are in plane M that are not all in one line. Because if they were all in one line, they could be in other planes as well. Well, all 4 of the points in this picture, A, B, C, D, are all in plane M and they're not in a straight line. So you could really pick any of the 3 points, any of the 4 points there to be the 3 for your answer.
Do you have to name a postulate in your homework?
That's the justifying. Yeah, when we justify, we have to give the postulate or the theorem that lets us know that our answer is a good answer. So then we would look at the postulates and say, which postulate talks about 3 points not in a line making up a plane? And that's postulate 7. Next.
How do we know point D is in plane and it could just be off in space like we had?
It's true, point D could just kind of be floating off in space somewhere. If they wanted it to just be floating in space somewhere, they wouldn't have put it within the line boundaries. Like, it would have been over here, something like that. The next one says, name the intersection of planes M and N. So then we could think about our postulates and say, well, what do our postulates say about when 2 planes intersect? When 2 planes intersect, what are we supposed to get? A line. So we know our answer has to be a line. So it'd be the line AB. And the postulate that tells us that we get a line is postulate 9. Does line AD lie in plane M? Well, it's not there, but we could always draw it in.
Yes.
And when I do that, this is our connecting the dots on a sheet of paper problem. So A and D are both in M. If I connect the dots, I did that in M. So that's a yes. And the connect the dots postulate is 8. 2 points in the plane, connect them, the lines in the plane. And then 9, does plane N contain any points that are not on line AB. So in our picture, C and B are in M, they're not in N. A and B are in both. Is there anything else in plane N?
No.
Yeah.
There is. How do I know there has to be? Because there's no other names. So how do I know there has to be another point in there? How do I know a plane has to have 3 points? A line has more than 2 points for sure, so that would be one way. But how do I know a plane has to have at least 3 points? Which postulate says a plane has at least 2 points?
6.
Five.
Yeah.
Any questions on these? Yes.
What if a point was above AB, the line AB, but was still in the boundaries of N? Would it be on M or N?
We would have to be careful about drawing another point in that would meet that criteria. So if we drew it here, it'd be too hard for somebody to be able to tell, is that an M or is that an N? So either directions would have to tell us where that point is, or they would have to draw it either in this space over here where we can see it's clearly an N, or in this space up here where we can see it's clearly an M. Yep, otherwise it'd be ambiguous.
Alright.
Other questions on these problems? Okay, so when your assignment says justify or state a postulate, that's when you need to give one of these. You may give just the numbers instead of writing out the whole thing, that's fine. You can use your notes, and when it comes to the test, you don't have to have them memorized, so you don't need to worry about doing that. Okay, your questions are as printed on your homework sheet.